Greeks and solutions to quadratic equations. So we've seen how the Greeks handled one equation where you're looking for an unknown so that you can take a rectangle and add a square to it and have this rectangle and square be equal to another square. Well, another one of the problems the Greeks have is to take a rectangle and cut a square off of the rectangle and have what's left be equal to a known square. Now, that's what they're up to. The question is, how do you say this in modern language? Well, this is going to be my x value right here, my unknown. And so here's what we're up against. You want to have a rectangle, a times x, where I can cut off x squared and have it be equal to b squared. Now, that sounds just wonderful, and it's not that hard, but there is something we need to consider here. And permit me to rewrite this, and I'm going to move my x squared over. So I'm going to have x squared minus ax plus b squared is 0. And I'm going to use the discriminant one more time, which says square the middle, or square the linear, so I get a squared, minus 4 times the leading coefficient and the constant. In this case is simply b squared. And in order for this to have a real solution, I need this to be greater than or equal to 0. Well, that's fine, but all of a sudden we now have an interesting relationship. We're saying that a squared must be greater than or equal to 4b squared, or a must be greater than or equal to twice b. Meaning b must be shorter than a. Matter of fact, it has to be half of a at most. So we do have a limitation. It's not all equations of this form. It's only those equations where b has a particular value. Let's watch how this is going to unfold. And let's take a look. So now all of a sudden we see that I've got my geometry drawing information up here, and I've given us a length A and a length B, and I have made B relatively short compared to A. It's less than half of A, so that we can see the solution. Now, how are we going to do this construction? So the Greeks, namely Euclid, is going to say no problem. Let's begin though with the segment A. We have to start somewhere. Well, just like the previous example, we're going to need to see A somewhere. We're also going to need to see B somewhere in this illustration. But this time, B is not going to be hanging around at the end of A. In this case, I need to, before I go too far, find the midpoint of A. I'm cutting the length A in half. And at that location is where I'm going to build a perpendicular segment that has the same exact length as B. Now, with this, you're probably thinking to yourself, so what? Let's watch what now happens. Let's construct the solution. And here's the solution. At this point up here at the top of the length B, construct a circle. And the circle is going to have as its radius the length 1/2 of A. So that means the length from here, this point, down to here where I hit A is 1/2 of A. The claim is that this little length right here is the missing length that will say, hey, here's how you build your rectangle and your square so that the rectangle take away the square is equal to the square that lives on the segment called B. Let's take a look. So now, let's build our, sorry, not that one. So here is my rectangle. This is my rectangle A times X. It has the length of A, and it also has this height of X, because all I did was take a circle and swing this length down. But what we're interested in doing now is removing the square. And so that's what we're going to do. So there's the area of the square. We just wanted to take it away. because what we're interested in, if you remember, is ax minus the square. So what you see left over is what is supposed to be equal to the square living on B. Well, let's take a look and see if that's true. I'm going to grab these two areas and we'll go up here and measure, and if all comes out well in the world, I'm going to get the same number twice. And lo and behold, I have. And I can change the length of B, and my numbers will remain equal. But remember, B must remain shorter than half of A, because if not, the circle doesn't hit the segment anymore. I can also change the length of A, and all that does is change what I'm seeing in the way of how the rectangles are shaped.